So a very good day, doctor. So today I'm here to present my topics on synthesis, characterization, DFT, and conductivity study of thermosemi-carbon derivative and their transition metal complexes of copper, zinc, and nickel. So my name is Yong Sin E and my matrix number is S70959 and I'm from K1. So in this presentation, I'm going to present my introduction of title, literature review, methodology, and also expected results that I have wrote in my proposal writing. First of all, the thiosemicarbazone actually is a compound that contains tyrosemic backbone, azomethyl groups, and also thione group. So, in the thiosemicarbazone derivative, actually they can exhibit the thione-thiol tautomerisms. So, in chemistry aspect, thiosemicarbazone actually have many uses, such as it can act as gelatin ligands that coordinate to the metals through the lone pair on the azomethyl nitrogen sulfur atom from the thiocarbonyl groups or any other donor atoms on the substituent, which is the R group in the pictures below. And also, thiosemicarbazone can form complexes with the metal ions such as zinc or copper, and then they will exhibit the biological activities. And lastly, tyrosemic also used as catalyst in the organic transformation reactions. The tyrosemic derivative can be synthesized through the condensation reactions between aldehydes or ketone with a tyrosemic carbazide. For example, acetophenone tyrosemic can be synthesized from acetophenone and also tyrosemic carbazide. Next, the methods or techniques that we usually use to characterize thiosemicarbazone derivative is IR, NMR, and also UV-Vis. Okay, so in DFT, density functional theory, in generally, it is used to calculate electronic structure of atoms, molecules, and solids. But in this case of tyrosemic DFT is focused on electronic, structural, and also reactive properties of tyrosemic and it is used to make prediction of compound stability and the nature of charge transfer in coordination complexes. And also in DFT, HOMO-LUMO analysis will indicate the compound stability and the potential to be a ligand. Okay, so next is conductivity studies. Conductivity is defined as a transfer of energy through the contact with a material or materials. It is to test the conductivity of the electric currents or ions in the tyrosemic. So usually the conductivity is influenced by the molecular structure, ionization potential, and also the presence of coordinating metals. So the problem statement in my proposal writing is that too limited exploration into the use of innovative materials or alternative materials such as thiosemicarbazone-based metal complexes, which will show the potential for addressing issues of the demand of this kind of materials. So there are four objectives in my research. So the first one is to synthesize tyrosemic derivative and their transition metal complexes with zinc, copper, and also nickel. The second one is to characterize the compound synthesized. The third one is to evaluate the conductivity properties of the compound synthesized using CMC and also PC through the EIS spectroscopy. And lastly, to perform the DFT study to analyze the electronic, structural, and also molecular properties of the compound synthesized. Okay, so for the scope of research is very similar to the objective of research. So before we proceed to achieve our objective, the main thing that we need to do is to develop efficient synthesis routes for these compounds and also focus on optimizing reactions conditions to achieve the high yields and also high purity of compounds synthesized. So in a literature review, based on my study on the article for Domets et al. And also Bashri et al., the things that I can conclude is that the synthesis of tyrosemic is through the condensation reactions of tyrosemic with either aldehydes or ketone. And both of these articles actually use the same characterization technique to characterize the compound that they have synthesized, such as FTIR, proton NMR, and also carbon NMR. So in FTIR, there are four important peaks, which is C double bond O, C double bond N, C double bond S, and also N single bond H. In proton NMR, there is some peaks that is important, which is proton of thione group, protons of hydrazone groups, and proton in thiosemmic carbazone groups. And whereas in carbon-13 NMR, there is two peaks important, which is C double bond N and C double bond S. Next, I also investigate some of the factors that influence the conductivity studies, such as chemical structures, degree of ionization, solvent effects, temperature, and also the presence of substituent of thiosemmic molecule, which is the I group. So the methods and techniques that I will use to synthesize and also characterize the tyrosemic carbazone derivative and their transition metal complexes is that I will use CH and S elemental analysis, FTIR spectroscopy, proton NMR, carbon NMR, UV spectroscopy, TGA analysis, magnetic susceptibility, X-ray, and also molar conductivity. To measure the DFT, I will use the Gaussian 16 and also Gauss Wheel 6.0 for the visualization, and for conductivity studies, I will use EIS spectroscopy. So here are some results that I expected to get during my research later. For example, in FTIR, I expect to get two peaks for NH stretching, one peak for NH bending, and then one peak for C double bond N, one peak for C single bond N. And if the tyrosemic carbazone derivative is exhibits in tyon form, I expect to get C double bond S peak at around 800. And also if it is exists in thiol form, then I expect to get S single bond H peak at around 2500 to 2600. So in proton NMR, there are three important peaks, which is thioamide, aromatic protons, and azomethyl proton that must be exits in the results with following values. And for the carbon NMR, there are five very significant peaks, which is thioamide carbon, C single bond F, C double bond N, C single bond N, and also aromatic carbons that must be occur in my future research. So for the conductivity study, the electrical conductivity of the CPCLH ligand firm mixture was found or must be around 3.7 times 10 power law of negative 9, must be around these values. So that is all from my proposal writing. Thank you very much.